Hello everyone, myself Prashanth, working as assistant professor in MLRITM college. Today we are going to cover the data types in Java. As a part of Java series lectures, yesterday we covered the variables. See, if I want to declare a variable, then I am going to use a syntax like this: int a equal to 5. So here a is nothing but variable, which is already covered yesterday. Variable is nothing but name given to a memory location, and phi is nothing but value or data stored. So what type of data we are going to store inside of this memory location means that is nothing but integer. So here int is what? Data type. So now we can define a data type. Data type means the type of data we are storing inside of a memory location. So what kind of data we are allowed inside in the Java? That is nothing but data types in Java. See, there are mainly two categories we can conclude. Like, there are two types of data types categories. One is primitive data type, non-primitive data type. These non-primitive data types also called as user defined data types. Primitive data types and non-primitive data types. Again, these primitive data types are divided into two types. One is non-numeric or numeric. Numerical data types and non-numerical data types. This non-numeric type of data types again divided into two. One is Boolean and character. These two are non-numeric, Boolean and char. And these numerical data types again divided into two categories. One is integral and another one is float. So there are two again subdivided, that is integral and floating. These non-primitive data types examples are strings, arrays, etc. So in this lecture we are going to cover only this primitive data types. So this we will cover next: arrays, strings, and separate sessions we are going to take. So the name already given, data type means the type of data we are storing inside of a particular variable is nothing but data types. So if you are storing a numerical type of data, then that is numerical data types. And the numerical data types are integral. One is where the fixed, the meaning is floating point. For example, 1.2, which is floating, and 1 is nothing but integral. So if you have the decimal points, then that is called as what? Floating point. If there is no decimal points in the data, numerical data, then that is called as integral part of data. So this integral part of data again divided into byte, short, int, long. The float again divided into float, double. In this lecture we are going to see what is the size and what is the default sizes and what are the keywords to declare a integer variable, byte, float, boolean, character. It is very simple but important, because without any data we are not allowed to write anything. We are not supposed to do anything without data. So it is very crucial part for any programming language as well as for Java also. So here we are going for how to declare and what is the keyword used to declare integral and floating and character and boolean, and what is the size and what are the allowed range, so that we are represented inside of a table. See, observe this table. This table explains what is the size of every data type and what is the default value, and also what is the range we can cover. This table covers everything. For your theoretical exam, this table is going for answer. So if they ask you in the examination, So what are the data types in Java? Then if you understand this table, you can answer it. So the previous one, just there are two types of categories, primitive and non-primitive. So non-primitive, we are not discussing now. So we are going with primitive data types. These primitive data types are displayed here. So the first one, Boolean. Boolean is non-integral data type which we are allowed to store only two values, either true or false. So here we need to use true or false. That's it. So in the previous programming languages like Python, there we are having 0 and 1 to represent false value 0 and to represent true value 1. But here we have to use true or false, that too non-quoted. So like this, the default value for Boolean is false. The example, either we can use true or false. So if you want to represent any true or false, only two options, then we are going for the Boolean type of data, right? So the keyword is Boolean, so that we will see. Next, byte. I will show you with one example. So first, next one, byte. Byte means 1 byte. 1 byte is equal to 8 bits. 1 byte is equal to 8 bit. The size of this particular byte is 1 byte, that is 8 bits, that is equal to 8 bits. As it is a 8 bits, we can allow 2 power 0 to some 2 power 7. So like that, so 2 power 1, 2, 3, 4, 5, 6, 7, 8. So 2 power 7, the plus to minus. So that is why the range is given minus 180 to 128 to 127. Any value we can store inside of byte. If you want more than that, then you are going for remaining data types. So next one, char. So just in the C programming, you will have character data type. So the main difference between C character and in the Java character data type is there you are storing ASCII values, here Unicode values. So this, as it is saving the character in Unicode format, that is the reason it is taking 2 bytes of data. So it is 16-bit character, we can use Unicode format. So the range is, as it is a 16-bit, we can take 0 will be included from 0 to 65,535 characters allowed in character. So that is why the range is 2 bytes. So it's a Unicode character. So in C it is ASCII values. So the Java character type data type is, the type of format is Unicode format and the size is 2 bytes and the default value. So if you are not initialize like this, if you use character C and if you are printing system.out.println, so then it is going to print what? It is going to print the Unicode value, that the default value. So the default value is /u triple 0000. And another type of data type, that is short, which is numerical data type. So the short takes 2 bytes of data and the range is from minus 32,768 to 32,767. So next one, integer. The integer is 4 bytes and which is taking the value range from this minus 2,147 to that plus 2,000 it's 2147. So we can say minus 2 power 32 to plus 2 power 32 you can take. So long data type is 8 bytes. Always it should be suffix with L. Long data type, if you want to declare in Java, so that value must be L. Float, the float is also you need to represent with F. And to declare double value, you no need of any suffixing with D, because the default floating value is in Java is double. So here we are having, so totally 2 categories of data types. So here Boolean, the Boolean is, the size is 1 byte, the values are true or false. What are the values allowed means either true or false you can use. 0 and 1 not allowed, and the default value is false. Character, it is a Unicode character, and what is the size? 2 bytes. And what is the default value? U0000. In the same way, integer, here byte, 1 byte, it is 2 bytes, it is 4 bytes, and it is 8 bytes. Here, this is float is also 4 bytes, the double is 8 bytes. And what is the difference between float and double? In the sense, it is a single precision, means after decimal how many values you can store? Single precision. Here double precision we can store up to n number of, means it allows only 4 to 5 values after point like 1 point, some 1.2456 so only some 5 to 6 values the float will be stored here. Maximum range we can take for the double. So it generally we are going to call it as double precision and single precision. So based upon the our usage and based upon the application, either we can use float and double. So the default is double. The default floating value of Java is double. If you want to declare the float value, it always recommended to suffix with f. So now we will see how to declare and what are the characters or what are the keywords in order to declare every data type with a simple program. So that simple program is this. So here this is the byte. So byte, in order to declare a byte variable, then definitely we have to use a keyword byte. So short, short, short is a keyword to declare this variable. So the range of values, either any one we can use. For example, if you declare 32,768 inside of this, you are going to get the out of range, means we are going to get the error, compile time error we are going to get. So only this range is allowed. So if you want to more than this, beyond this, then go for the next level, that is that integer. So if you want to store 32,768 value, so then go for the next level. If you want to save or you want to store a value inside of integer data type like this 48368 plus, so then you go for what? You go for the next level long, and always it is signed. So the data storage is also separate. For example, if you are taking 8 bytes, so if you are storing byte, so some 0 to 1 2 3 4 5 6 1 2 3 4 5 6 7 8. So 0 1 2 3 4 5 6 7. For example, 127, the binary equivalent value 127, for example 127 2 so if for example if it's storing 0 1 1 1 1 1, assume like some value I am taking, so 0 1 1 1, whether it is plus or minus, the sign bit we are storing here, signed bit we are storing here, the signed bit we are storing here, and the some value any one some value that will be stored inside of the binary 0 1 1 1 1 1 like that. So 2 power 0 2 power 1, so like that the binary values will be stored here. The last bit, what I am trying to say is the most significant bit will be representing sign, either plus or minus. The most significant bit either plus or minus 1. So I have taken a simple example. So any binary equivalent value will be stored here. So the last bit will be plus or minus. So all are sign. The meaning of sign here is that. So I have taken simple example 0 1 1 1 1. So how it is going to store the binary equivalent value? So if in order to calculate the binary equivalent value, so you divide like this, you know the procedure. So I am not discussing that, just I want to convey only the most significant bit is what? The signed value. So the last bit will be signed. So that's why always we are taking the first bit, the first bit will be the most significant, will be plus or minus. So integer, long always with L, floating always with F, double not required. The default value, the default in Java is double, and these are all printing statements. So this is the way of declaration. So the next thing, so this is declaration, and what is the type and size. Is there any type conversion is available? Yes, we have two types of conversions. One is automatic type conversion and narrowing. So here automatic type conversion, in the sense, if you observe, this is in ascending order. This is the shortest, and more than big, 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 and big. These are all integral and floating range of data types. See, if you declare int a equal to 4, some int a, and uh, short b is equal to 4, some 5 I am taking. So int a and short b is equal to 5. So a, b, for example, I want to store a inside of b inside of a allowed, because it is automatic type conversion. So what I done here, I declare a variable a which is type of integer. Inside of this integer I am storing the small value b. It is allowed, automatic type conversion. For that you need to write any extra code for it, automatically type conversion. So we are increasing the capacity of a variable here. So that is why we are calling it as widening. So this automatically done by the JVM, done by the Java. We no need to write any code for this. So that is why it is called as automatic type conversion. And when coming to the next explicit, we need to explicitly write. So for example, you see this here, I have a variable double value. So double value is what type of data type? It is a double data type. So now I don't want to print this 0.78. I want to print only 9. Meaning is 9 is integral. So what you're trying to do is, the more value or the bigger range of data type inside of the smaller value. So in the exact opposite way you are doing it. So here the integer you are trying to store inside of double, opposite, exact opposite you are doing. So then the type converting is called as typecasting. The typecasting is nothing but explicit type conversion, is also called as explicit type conversion, is also called as narrowing. Here the largest one you are taking and you are compressing it. So that is why we are calling it as narrowing. So the conversion operator is this, the typecast operator we are going to use this. So example here, this is the example. So here this double value is converting into integer. So for that purpose we are using this operator. So this is generally called as implicit type conversion. Sorry, explicit type conversion. This is explicit type conversion. So but if you want to go for implicit, there is nothing. So there is no code I used here, or no other any programming knowledge is not required. Automatically it is going to be done. So here integer value I am taking 100. Here I took long value, and inside of that long I am storing integer. So this is implicit. No further knowledge or no further is required. So it is automatic type conversion. When coming to here explicit, which is narrowing, this is also called as what? Widening. So there are two types of type conversions are there. widening and explicit typecasting and that. So what we covered, so there are mainly two types of data types, primitive and non-primitive data types. Under the primitive data types, we are having numeric and non-numeric. Under this, we are having Boolean and character. Under this, we are having byte, short, int, long, float, and double. The way of declaring is this, and here the size is this. So the way of storing inside of the memory is equivalent to the binary, means we are converting that into binary, and first 7 bits will be what, the data, and the last 8th bit is what, which is most significant bit is what, it is plus or minus sign. And the automatic type conversion or typecasting will be either widening or narrowing. So this is by defaultly, and this is we are using with this operator. So that's it. In the next class we will see operators.